Hello everyone, welcome to the episode 1 of TFK Deep Learning. This episode will be about a very complete overview of the neural network and deep learning. So there are a lot of tutorials available there, but I just wanted to brush up everything once before we enter the implementation. So that's what this episode will be. And before we go, let's have a recap of the previous episode. So previous episode was a tutorial series introduction where we just discussed what deep learning is. It's a hierarchical learning, giving end-to-end learning. And we also discussed what is the approach that we'll be following in this series. We'll be looking into basic theoretical concept, not in much in depth, and then implement in TensorFlow, and then implement by mixing both TensorFlow and Keras. Said that, let's go to episode 1. And in this, we'll be just looking at what is artificial intelligence, what is ML machine learning, what is neural network, what is deep learning, different kinds of learning, structure of a single artificial neuron as well as artificial neural network, and then we also see a basic flow of training any deep learning algorithm. Okay, so the ultimate quest is to achieve artificial intelligence. So when you just Google what is artificial, something which does not occur naturally, something produced by human. And what is intelligence? Its ability to have cognition, reasoning, to learn and acquire and apply those skills and knowledges. So this term artificial intelligence was coined in 1956 by John McCarthy. And when I Google this just to have a definition, so it says this. So artificial intelligence, it's the theory and development of computer systems or machine, which is having the ability of like human intelligence, like a visual perception, speech recognition, decision making, translation between languages, etc. And not only all this, it should also be able to perceive the environment, like, and take actions in that environment to achieve some goals. And it should obviously have mimicking power of cognition, and it should have the power of learning and problem solving skills. So that's what broadly defines artificial intelligence. So I am a big fan of Friends. So if you take Friends as artificial intelligence, what could be the six people in artificial intelligence that would make a very good gang? So it would be Ross as a visual perception, Rachel as speech recognition, and Monica as decision making. Chandler is taking actions, Phoebe as natural language processing and translation, and Joey, ironically, learning, reasoning, and memory. So all this six group of things broadly will make the friends of artificial intelligence. Said that, so if you take artificial intelligence as a tree, so this AI is the root and its branches being all these different techniques like neural networks, machine learning, deep learning, genetic algorithm, data science, stats, reinforcement learning, pattern recognition, and all its application being its leaves like recommender system, chatbot, NLP, image captioning, scene understanding, object recognition, generative models, generating images and text, and many more. So this is just to give you a picture of all the application just arising because of the our quest of having this artificial intelligence. So said that about artificial intelligence, we know we all started with programming, which is like we write some code, some instruction, which we want our machines to execute, and the machine will execute that instruction. But it gets tough in every situation to write, so suppose you consider self-driving car, it will be really tough to write exact code for it to take actions in different situations. In that case, it will be more better if it could learn by itself, and that's why machine learning. So machine learning, it's a branch of AI based on the idea that any machines or computer, they learn from examples, from experiences themselves without being explicitly programmed, and they evolved from the study of pattern recognition. And now in this actually in this in this decade, we are able to harness this ML or DL powers because of the availability of more data, affordable computation, inexpensive storage, and obviously powerful libraries. And the process of learning begins with observing the data, learning the hidden pattern in them, and then applying it, the real time. So if you consider Consider this situation, like your teacher in classroom teaches you some maths problem, like 2 cross 3 is 6, 3 cross 3 is 9. So when she teaches you, you learn the pattern. 2 cross 3 means 3 times we add 2, it's 6, 3 times we add 3, it's 9. So we learn the underlying pattern of these problems. And once we learn it, then in your examination, even if they ask you a new question, we once we know that pattern, we have learned that pattern, we can use this new problems, like we can solve that new problem using the learned pattern or learned technique or whatever during our training in the classroom. So that's what is machine learning about. So we learn from the we learn the actual underlying pattern from the data, and then we can apply it in the real test environment. Okay, and one more example will be, suppose you have a automatic door opening system, and if you just program it having a sensor, so if anybody comes, the sensor senses it and it opens the door. But what if it, like we apply some ML and it also learns the face, automatically learns the patterns of the face, and it will open only when some particular face is recognized. So it obviously, improves the system. So there are a lot of ML examples which you use in daily life, like recommendation system. When you go for online purchasing, when you buy something, the website automatically suggests you some more products. So it has learned your pattern of shopping or the products you like, and it will suggest according to that. And even in YouTube videos, like it will suggest you similar videos which you have been watching from past few days, or depending on your search pattern, it will suggest its own. So it learns the pattern. That's what ML does. And other is, automatic tagging in Facebook. So it automatically tags you in Facebook by learning the faces of your friends. And obviously the voice recognition in, Google Home or Amazon Alexa, they learn the voice pattern. And then object recognition, it's all about learning these patterns from the data. And it's like applied to huge number of application now. So, and recently Google Lens was launched, and you point to some object and it will recognize it and give you a description about that. So this was about the meatball shop, and even you can automatically connect to Wi-Fi just pointing at them. And mail categorization, you would have observed that your Gmail, for example, it automatically categorize your mails in primary, social, promotion. So it learns the pattern that which could be social, like YouTube is social or LinkedIn is social, and promotion, SpiceJet, it's a airline flight, it's a promotion, and something kind of that. So I hope you got the idea of how it's applied in real time ML. It can be in fraud detection, spam, non-spam, email classification, NLP, computer vision, face reco, object reco, self-driving cars, and many more. And if you go by definition, then authors ML define it as machine learning field of study that gives computer the ability to learn without being explicitly programmed. And it's another definition, like where a computer learns from experience E with respect to some task T, and we measure it with some performance P, and its performance P should improve with experience E on the same task. Okay. So there is a very good course of ML by Andrew Ng, and even he launched deep learning course. So I'll you can just go and take this course if you're new to machine learning. It's really great. So enough about machine learning. So let's see what a neural network and deep learning is. So this is a definition I took from the ebook by Michael Nelson. So I'll give you the link of this ebook. This is really a very good book if you want to grab the theoretical concept of neural networks and deep learning. It's really an amazing book. So, and I really like this definition that neural network is a beautiful biologically inspired programming paradigm which enables a computer to learn from observational data. And deep learning is a powerful set of techniques for learning in the neural networks. Okay, so yeah, but before we go into the neural network, let's see how this learning algorithm works, or the traditional approach of learning. So let me consider a case of supervised learning. Supervised learning is a type of learning in which we give the data and also we give its output. If you consider this class of car detection, then we give its output whether this object is car or not a car. So we label this as car, we label this as non-car, and we give it for training. Okay, so what happens, suppose if you this all actually these few slides are taken from Andrew Ng lecture, and that lecture is really good. I'll post the link of that also, you can listen to that lecture also. So suppose you want to like detect classify the car from the non-cars, then you are taking suppose this pixels here, and you're mapping it, suppose pixel 1 and pixel 2, and you are taking pixels from your non-car and you're mapping it. So you just plot it here, and similarly you keep on plotting all those pixels here for car and for non-car. And then once you have done that, then we make a decision boundary which classify car from non-car, and anything lying here is a car, anything lying here is not car. But in real scenarios we cannot take the raw pixels, because if we take raw pixels, it will be very ambiguous if for different images, for like complex classes and more number of classes, it will not be linear or very clearly separable, it will be really mixed up like here. So it will be very tough. So what we do is, instead of taking raw images in any ML approach, we try to get its features. So features are the high level representation of the image, which will clearly separate it from other categories. So like for example, boys and girls, maybe the hair could be one feature, could be one, and many other things. So in this case of suppose bike, instead of taking raw pixels, we are taking features. Features could be handles and wheels. So this is a feature which will separate bike from other stuffs. So now, instead of like plotting the features in pixel level, we'll plot it in terms of wheels and handlebars. So in this case we can easily separate this motorbike from other classes, because it will be those bikes, they'll be having the wheels and handlebars, and the non-bikes won't be having it. So this is how anything works. We take the image, we take the feature, and then we feed into the learning algorithm, which will learn the decision boundary, like the previous case. Okay, so the features will be kind of edge, maybe this kind of edges, and we'll represent it in some feature vector. So basically, for any learning algorithm, we need two things. One is feature extractors, which learns the feature, and a classifier, which extract the features, and a classifier will learn the feature. So we'll have an input image, we have some pre-processing step, then we get the features using many techniques, many traditional computer vision techniques like HAR, HOG, SIFT, SURF. And I'm talking all this in respect to images, computer vision, but this applies even to text or audios and any other thing. And then from the features like here, then we give it to learning algorithm, and which will learn whether it's cat or a background. Okay, so there are a lot of features extractors there. These are hand engine feature extractor like SIFT or SPM, and then hog and Swift are quite famous. And so these all are called hand engineer features, because they're domain specific. They have been done, like a lot of researchers have done a lot of experiment and then finally come up with this. They've hand engineered this, like this famous one, hog, Swift, Gabor filters, local binary patterns, or har, etc. And we can also not like this those are engineered features. We can also obtain features by learning those. This comes in deep learning by using CNN. And then we have a lot of learning algorithm like KNN, naive Bayes classifier, LDA, SVM, very famous, logistic regression, or neural networks. So this is how the like your basic ML works. We get features and we fit into a learning algorithm. Now let's again go into our neural network and deep learning. I told you the definition here. So if you say what is neural network, so it comprises of two words, that is neural and network. So neural meanings the neurons, actually the basic unit of neural system. So if you take biological, uh, let me take a pen here. So if you take a biological neuron, it looks something like this. So you will have inputs coming here called dendrites, and then output going, this will be axon, and then this is the output, output units. And if you take the artificial neuron, so it's kind of inspired by this. We'll have the inputs, and we'll have a cell body like this one, nucleus here, and then we'll have an output. And this is the basic unit, and when these are connected together, they forms the neural network. So this is the biological neural network, and this is the artificial neural network. They both comprise of basic neurons, biological neurons and other artificial neurons. Okay, so this is the similarity which I was talking. So let's understand the simple structure of a single artificial neuron. So a single artificial neuron will have inputs, and each of the inputs will be weighted by some values. So depending on whether this neuron, what it is looking like, suppose this neuron want to take only like some amount of feature x1, some amount of feature x2, and some amount of feature x3. So it need to weight it with some value, and then we sum it. We sum the weighted product of the input. We add some bias term. So bias term is another parameter like weights should be added to it, and then we apply a activation function. So as the name suggests, this activation function will see whether this neuron is getting activated with this input or not. So there are a lot of activation functions. For example, suppose you consider a sigmoid activation function. So for sigmoid, if your sum of product x is large, then it will be activated. Its value will be closer to 1. And if it is a small value, your sum of x means your sum of weighted sum of x, then it will be 0. It will be close to 0. It won't be activated. So this is a excuse me, a numerical example showing that. So if you're aware, this x term was quite large, 11.34. So my fx was close to 1, the activation function. So this neuron was getting activated. So this was one activation function, sigmoid. So, there are like number of activation functions like 10H, which squashes the input between 1 and -1. Sigmoid we saw now, it squashes the input between 0 and 1. And ReLU, anything less than 0 will be 0, and anything above 0, it will be linear. And there are a lot of variant of ReLU like leaky ReLU, parametric ReLU, or exponential linear unit. So the role of activation function is to induce non-linearity in the network to learn the complex non-linear functions for the non-linear data. So activation functions really play a very important role, and there are a number of activation functions which you can choose while implementing your network. Said that, now since we have seen a basic structure of neuron, how we can construct a neural network from that neuron. So for any neural network, it will be having a number of neurons, and each neurons will have that basic computation unit which we discussed few slides ago. So for say, let me take a pen. So say for this neuron, suppose it will take input from the previous neuron. It will apply. It will do the weighted sum of product. It will apply activation function, gives it output. And then if we move to the next neuron, it will again do the same computation. Then we move to the next neuron, it do the same computation. And similarly, we can construct this entire network by using this computation unit. This is the basic computation unit of any neural network. So the neurons will be arranged in different structure, and they will have, depending on that, they will have different names or different, you like CNN, RNN and all, but the basic computation remains the same of computing a single neuron output and then applying the activation on it. Okay, so I hope that is clear. And let's go from shallow to deep network. So shallow meaning the network which have just one hidden layer, and deep meaning a number of hidden layer, like deep network, really deep network. So let's first see deep learning, as we discussed even in the episode 0, that it learns feature in hierarchy. So there will be number of layers. So that's why it's called deep neural network, and each of this layer will learn features in hierarchy. So from pixels, the initial layer will learn some features like edges. From edges, the next value will learn like features of object paths, combining those edges. And then the higher layers or the deeper layers, they will learn higher level of features. Okay. And yeah, so this is image from the paper by Fergus and Zahler, where they visualize the features through some deconvolution technique. They are able to see that actually the layers are learning this kind of features at different depth, different features, different hierarchy of features are being learned. So if we move from shallower to deep network, so let's say initially we have just pixels, we apply classifier and we say bus, but it was obviously not robust. Then we go for some features like edges, and then we put classifier, but edges alone are not very good features. Then There were a lot of hand engineer features like combining edges, histogram, and techniques like shift, hog, etc. Those will get the features, and then we put a classifier and then learn from it. Then again, another like more deeper network, like we have edges, histogram came in sparse code, and so on, and then the classifier. So we are just moving from shallower to deeper in order to get more good features. So each additional layer signifies learning of higher level of features. Okay, so in deep learning, it's actually, as I've discussed earlier, it is end-to-end learning. So instead of like let me go, yeah. So let me explain with this slide. So this where we have an input and we have a hand engineered feature extraction technique and then classification of whether it's a car or not car. However, in deep learning, in a single network, we combine this both feature extraction as well as classification part. So if you see in the traditional approach, we have feature extractor, features, traditional ML output. But in deep learning, it's end-to-end learning. We give input, deep learning algorithm, and the output. It learns the feature as well as the classifier between those features. Okay. So if we see this image, this part is gone. This part of feature extractor is gone. Okay. So that's why it's called end-to-end learning. So as even in episode 0 I've said, we can not only apply to images, even in other field like audio and text, it provides the same end-to-end learning. Okay, great. So it has two important things which we have discussed. It's end-to-end learning and hierarchy of features. So any deep learning approach will give training data, suppose dog, cat, and it will pass through all these layers and it will learn. And whatever error we get, we feedback the error, it corrects itself and finally learns it. And once that algorithm is trained, we deploy it, we give a test image, it goes through the network, and then we recognize it as dog or not dog. Okay. So let me talk about ImageNet. So it's a very ImageNet is actually a huge collection of images, as it says here. It's provided by Stanford. So there are 22,000 categories of images, 22,000 categories and 14 million images, having this animal, plant, structures, and all this thing. You can go and have a look at it, imagenet.org. And so for ImageNet challenge, it's a big competition where all these researchers or the companies or practitioners, whatever, they come and test their algorithm. And the challenge is to recognize 1,000 object classes among this many images. So as you can see here, as we are progressing, this old uh, you know this old image, but the error is reducing, and that's because of deep learning coming in picture, especially CNN for image cases. So that's the revolution of depth. You can see in ImageNet challenge 2010, the error was this much, and this to a shallow network. And then in 2012, when the first CNN came, and it really revolutionize everything, the deep learning thing. So there they are having 8 layers. Then in 2013 the error reduced to 11.7. They're having 8 layers. In 2014 they had 19 layers. VGG network, it's very famous. And 2014 Google Net, it had 22 layers. And in 2015 residual network, which has 152 layers. So you can see how depth the network has been now. Okay. And yeah, just to visualize it, this is AlexNet, which came in 2012, 8 layers. Then came the VGG net, which is 19 layers. Then came the Google Net, which is 22 layers. And then came the father of all, ResNet, 152 layers. Okay, so that's pretty cool. But the way the network is connected in residual network is a little different. The structure of residual network, it's not just connecting directly, it's stacking on one top of another. So that's a different topic to discuss. So the deep learning is balanced by two things. One is data and another is large network. So if you see this Andrew Ng presented this, and in his graph we can see that as the amount of data increases, the performance of deep learning increases. Whereas in case of old learning algorithm, even when the amount of data were increasing, there was not much progress. And if you see in more clear way, then you can see when the amount of data increases, this is a traditional algorithm, this is a small network. So if data is more, and suppose data is more here, and the network is large, then the performance is really the best. So both plays important role. Okay, so to summarize now whatever we have discussed, so the broader picture is artificial intelligence, computers having the ability or to mimic and reason as humans, like self-driving cars or robot interacting with human, Google Home, etc. In machine learning are techniques giving the computers the ability to learn without being explicitly programmed, like for decision tree, logistic regression, SVM, etc. And then deep learning, a subset of ML comprising of neural network learning features in hierarchy and uh, learning from big data and like capable to adapt to new data. So structures like CNNs and RNN, etc., which are very deep and have uh, learning features in hierarchy. So that there are different types of learning or task based on the feedback from learning system. We can have supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning. So supervised learning is very common. Even I mean, yeah, you'll see all this CNN, object recognition, and all are based on the supervised learning. Then there's unsupervised learning, and we will talk about it. So let's see first what is supervised learning. So in supervised learning, we'll have the input as well as we'll have the output. So suppose we want to do the scar detection, we'll give the data and we'll label it as scars. We'll give this data and we'll label it as non-cars. And then we feed into the algorithm. And the algorithm learns based on the feedback, based on the ground truth, which is already knows it. Okay. So we'll have these features like this. So we will know it that these features whatever we plot, this belongs to cars, these features belongs to non-cars. Now we have to learn a decision boundary which will separate these two, and anything which falls here will be car, anything which falls here will be non-car. So this is supervised learning. In case of unsupervised learning, we will not have any label like before. So there will be data here, there will be data here, and those data will be in mixed form. So we will not say that this group is car, this group is not car. We'll just have data. If you see on this graph, then this data will be just on this feature space. This data will be just be plotted here, and we will not be knowing whether this is class 1, class 2, anything. There will be just data, and based on their structure, we'll kind of cluster it. So we'll cluster this based on their their features, or what to say, their characteristic. We'll learn this, and then we learn the decision boundary. Whereas in semi-supervised learning, it is something in between both. So we'll have small amount of labeled data and large amount of unlabeled data. So this is the example here. So this is the labeled data, circle and triangle. This is the label and unlabeled data. So there, this small dots are unknown stuff, and the circle is okay. We have labeled it partially, and based on this, now it will try to learn. So this it will see that whether this two data are close to this. Suppose this circle, then they will try to cluster among themselves, so they will become this class. And these points, they will see they're close to this, they will try to cluster with this, so they will become the next class. And then we learn this decision boundary here. Okay, so in supervised learning, as I said, we already know both the classes, we just learn this. In unsupervised, we don't know anything. In semi supervised, we know partially. And another interesting type of learning is reinforcement learning, where we'll have an agent and it will be in one environment and it will perform some action. And based on his action, it will be given some reward. Okay, so there is no supervision, only one reward signal. And if the agent is doing good, the reward will be positive, and if agent is doing bad, the reward will be negative. And the aim of learning algorithm is to maximize those reward, and in that way it learns environment. And it's really famous, it's amazing. It's amazing type of learning network. So that's what reinforcement learning is, and it has been implemented in a lot of gaming stuff. So you can see, you will be knowing all this kind of games. So these are the deep learning or reinforcement learning algorithms or the agents in this environment. and these are the agents in this gaming environment. And it became very famous. It was in news also when one of these reinforcement learning algorithm defeated the world champion in a game called Go. So it's a really tough game, but it was able to defeat it. It was developed by Google's DeepMind. So if you see this type of ML, then in supervised, it's task-driven regression classification, unsupervised, data-driven. So it tries to cluster by learning the features which is close to each other. And in reinforcement learning, there are agents which learns to react to an environment and survive that environment or even excel. So let's come to supervised learning. So there will be two type of task, mainly regression and classification. So uh, regression problem will have to predict a real value. So consider this example of a housing price. So you have house size and there are price based on the house size. So these are the plots or the data points for them. So you can see based on the input, the output is one real number. So suppose the house size is suppose 3000 square feet, then maybe the house price will be, if you generalize this algo, maybe somewhere here. I don't know, maybe here or here. So it will be something around $3,000. So you see based on the input, the output is some real number. So that is regression. Another example is this. So you given some temperature value, how many ounces of water you have to drink. So it's a real number, and once it is trained, you will be given the input, which is the temperature, suppose 95 degrees, and you have to predict how many ounces of water to drink based on the learned model. And in this case, the learned model is this. So you can compare it with the equation of straight line, where m is the slope and c is the intercept. So we, based on the x, we first learn the, based on the x and y, we learn the m and c. And once we have learned it, then we give some new x for which we don't know the y, and then we can compute the y by putting in this model or in this equation. So that's what is regression. And classification we've been looking at. So there will be categorization. So like in the male case or in the face recognition case, where we have this features two sides, and we have to learn the decision boundary. Any features on this side of decision boundary will be class 1, and anything in this side will be class 2. Example is this face recognition or male categorization. Okay. And based on the depth of network, we can have shallow network or deep network. So shallow network are the network which is having just one hidden layer, and deep network are the network which is having number of hidden layers. Okay. So there are number of neural networks. These are some name like, deep convolution neural network, deconvolution, or GAN, deep residual network, and RNNs, and many things. So these are all the units. And whatever the network is, as I told before, the structure will be different, but the computation unit remains the same. Okay, we'll look into it in later videos. So this is the computation unit. This computation unit remains the same, and we can have like different structure. So if we consider deep neural network, is a fully connected network, and this is the convolution neural network, where these small structural neurons which we discussed are arranged in 2D format. Okay, this becomes the CNN based on the structure and how the inputs are fed, and the network propagates. And then recurrent neural network, in which we have a loop means we have some memory. So it will take input not only from the input but also not only from this input but also from the previous state. So in this, the networks are arranged in different format. So the neuron remains the same, but the structure changes. And there are another network like GAN, general adversarial network, which are able to generate these images and all. So there the structure is different. And then the recently paper by Geoffrey Hinton, the godfather of deep learning. So he released he wrote one paper, last month or this month, about capsule network, where the structure is different, but the neurons, the computation remains the same. So that was about neural network. And let's see a basic flow of any learning algorithm. Any deep learning algorithm will have a data set. So we'll divide this data set in three or two, like we'll divide in training data, validation data, and test data. So training data will be feed into the algorithm, and then validation data, it will validate how much good the algorithm is. And once the network is trained, we'll finally test it on test data and measure its performance. Okay, so for if you want to understand any learning model of any neural network or machine learning, you just remember this equation of line, or y equal to mx plus c. So if you consider the supervised case, so in this case we will know x, which is the input, we'll know y, which is the output. Okay, so we'll plot it all this x and y, and based on that we'll learn this line. Okay, and learning this line means learning the features, the parameters actually, which is m and c here. Okay, so this m and c, which in neural network becomes weights w and bias b. Okay, so based on this x and y, the input data, we learn weight and bias, or m and c. And once we have learned it, that means we have learned our model. And then when any new input come, that is x, then we'll directly compute y with the value we have learned for m and c. So this is what any learning model is. So this is the basic computation unit. Let me consider this example. So this is, let's consider this is one input example, this is second input example, third input example, fourth input example, and this is the case of supervised learning. Okay, supervised. Okay, let it be. So this example has a class 0, class 0, class 1, class 0, and each input example has features of three-dimensional features. Okay, so we'll have three input neurons, and this is a hidden layer, this is the output layer. Okay, okay, so yeah, so now how we'll train the neural network. So what will we do is we'll first initialize with random weights value here, some weights value. Okay, once we have initialized the weight value, we'll take the first example, we'll feed it here. So this input will go here, and then we like this input will go here, and we'll do the computation as we discussed earlier. This neuron will compute, taking input from all these three, will compute some value, this will compute, this will compute, and then finally we'll have the output. So in this case, suppose it is 0.8, and our class actually was 0. So once we have done this, it is called actually forward propagation computation of 0.8. Then we compare it with target output, and we compute what is called error. Okay, so in this case, suppose if you are taking just difference, then error is 0.8. So this becomes an computation over all the training example. The overall error function is called cost function. So this is the equation. So this is for the case when we are just computing the difference, okay, mean square error. And then we'll compute the error, and the most used cost function is the cross entropy function. We'll look into this later. You can look in, there are a lot of theories available for it. So it will compare with the actual the predicted output and the true value, and then it will compute some cost like this same. Here we are doing difference, here we are computing log and all. Okay, so now once we have computed this error, so this error then will compute gradients. So gradients means based, like what to say, based on this error, like how much weights to change to rectify this error. So it will be rate of change of error with respect to weights or the parameters. We'll compute those gradients. Okay, and we'll compute the gradients using a very famous algorithm called backpropagation algorithm. So we will compute the gradients of all this using backpropagation, and we need to adjust this gradients based on how much error, based on like the what to say, the error based on the change in weights. We will then correct these weights. Okay, so yeah, then we adjust the weight based on the error and based on the gradients which we computed, the gradients of error with respect to the weights, and it will come do the changes in all the weight values from every layer. Okay, so once we have computed the gradients, how we can adjust the weight. So for that we need a optimization algorithm, and the optimization algorithm uses gradient descent, and a variant of gradient descent are used. Like there are a lot of them, like again gradient descent with momentum and a grad. atoms, and many things are there. So what this gradient descent does, suppose if you consider this convex function is your, if you consider two-dimensional case, if you have just one feature w, if you have just one feature w and the cost function, if you plot it, so suppose this is your cost function which is convex, and suppose you computed your gradient, means change in error with respect to the change in weights, and it was suppose here, then we'll move in the downside direction because we want the error to be minimum here. Okay, and if we are somewhere here, sorry, here, then we'll move in this direction, so we'll move down. So ultimate goal of this optimization algorithm is to move down and have the zero or the minimum cost function. And in actually in real time, the weights value will be very high dimensional, so we'll not get just this simple convex function. It will be some kind of, this kind of structure. And but ultimately the quest will be, our goal will be to just move downhill wherever we are and move to this minimum position, and this algorithm helps to do that. Okay, so we do this for all the training example and not just one. We feed it, we compute the error, we compute the gradients through back propagation, and we correct it through, gradient descent, and then we repeat this and the algorithm learns. Once it learns, then we can just test the data, and yeah, that's all. So this is how any flow of any learning algorithm is. And if you see in decision boundary perspective, so consider this green and purple data as two separate classes. So initially when you initialize with random weights, the decision boundary or the learned model will be wrong, like it will won't be classifying properly. But as you train with more examples, it will learn some structure, it will again learn, and eventually or finally it will learn a very good model which will uh, categorize these two classes. So anything above this is class green, or anything inside below this line is class purple. So this is how training on decision boundary point of view looks like. So yeah, so uh, now, yeah, so I think that's it. It was quite a long video, but my aim was to just give an overall, introduction of everything from artificial intelligence to neural network to, structure of a single neuron to how basic, like there is a basic flow of training a deep learning algorithm. And I hope I covered everything. So I hope you are fully loaded with the theoretical concepts and you are ready to go to the warfield and solve deep learning problems. But wait, you forgot your bazooka, the main thing to fight deep learning. The deep learning libraries which you'll be using to implement all those, the TensorFlow and the Keras. And I would like to give credit to all these people uh, from watching whose videos I learned, watching their videos, their presentation, and also I took number of slides from their talk in order to explain the concepts, and they really presented it in a good way, and I just used them just to share all the concepts. That's all, and I would like to thank them all. And tune in to the next episode 1.2, Introduction to TensorFlow, where we'll be discussing everything about TensorFlow, the structure of TensorFlow, how to write code in TensorFlow, and everything. So maybe in next week or 10 days, let's see. And till then, keep learning and keep exploring neurons. If you like this video, then hit the like button, and you can comment down your comments. You can subscribe in order to get notification, and you can support me financially on Patreon and PayPal, whose link will be given below. Thank you. Bye bye. Keep learning.